Hi, I'm Mr. Richmond, and this is your Unit 9.2 lesson summary. Unit 9.2 will be analyzing correlation using the correlation coefficient. That's what we'll be doing here on the right side. In addition to that, we need to be able to look at scatter plots and determine what type of correlation they have, and then make a general statement about the data in the graph. So let's start with that. In my first scatter plot, it's the time studying compared to test scores. And as I look at this data, it does look rather linear. It's somewhat forming a line, and it is slanting upwards. So it looks like it has a positive correlation. Since I know now that it has a positive correlation, I can make a statement about the quantities in the problem. So as time studying increases, because as I move from left to right on the x-axis, the time that a student is spent studying is increasing. So as the time studying increases, then test scores are also increasing as the line moves. So test scores are increasing. So this lets the person know that based on this particular set of data, that increased studying leads to increased test scores, which could be true. Seems reasonable. And the next one, as the number of siblings increases, IQ scores don't really do much. They're kind of all over the place. This to me looks like there is no correlation because the data doesn't follow any general trend. So what that allows me to say about the quantities in the problem is that the number of siblings you have does not affect IQ. At least according to this particular data, because there's no correlation there. And the last one, as I look at the data, it again looks kind of linear. I can see a general trend. It is, for the most part, working its way downward as I move from left to right. So that is a negative correlation, because the line is sloping downwards. And this means as the weight increases, because as I move from left to right, the weight is going up. As weight increases, life expectancy is working its way downwards as I move from left to right. So as weight increases, life expectancy decreases. Okay, so this particular data is stating that based on its correlation. Now what we'll look at in a future section is whether we can actually believe that statement is true. Is this what's actually affecting that, or is there other variables that we're not seeing that are causing this? And then the last one, it says, which is the likely R value for this data? If you remember, R is a correlation coefficient, and the closer R is to 1, this would be a perfect fit. So the closer R is to 1 or negative 1 is the better of a linear line it makes or an exponential function it makes. So for this particular data, I can look at it and go, well, it's going upwards, so I do know that R is at least positive. And that's going to limit my choices. Since R is positive, I know it can't be negative 0.08 or negative 0.11. It narrows my choices down to 0.88 and 0.11. Now, if a correlation is making any sort of general form, it's going to be pretty closer at least to 1. So I would expect, since this data does look rather linear, that it should be pretty close or closer to 1 than at least 0.11. This would be pretty much data that looks like this. It's all over the place. So if your correlation coefficient's above 0.75, it's kind of near the 8s, then that means it looks rather linear. You can see a positive or negative correlation of the data. So taking the educated guess here, this was likely the correlation coefficient. Okay, correlation coefficients above 0.7, 0.75 tend to make a line if your data is linear. If they're below that, 0.6, 0.5, 0.4, something way down here at 0.11, you wouldn't even be able to tell what the data is doing. It'd be all over the place. So as long as you have a general understanding of correlation coefficient, these type of problems shouldn't be a problem. And, all right, thank you and good luck.